what we're going to do in this little exercise is explore the mass ratio of two elements in a compound. Now, the compound is magnesium oxide. And what I've got here is a shiny piece of magnesium, and what I've got here in the air is a whole lot of oxygen. And what we're going to do is burn our magnesium in the oxygen and have a look at the mass ratio of magnesium to oxygen and see how that compares with what's regarded as the accepted, or what we might expect to be the value of that ratio. So our aim is to explore the mass ratio of magnesium to oxygen in magnesium oxide and to compare that with expected values. Let's see how we're going to do that. So what I'm going to do first of all is to make a coil of a 10 centimetre piece of magnesium. So I'll just wrap this up like this so that it will fit into our crucible here, the crucible with the lid. Now I've just got that coil there, so I've just got to weigh this now. I'll put that on the electronic balance, and hopefully you can see that says 0.23 grams, and I'm just going to record that on this page here, which says mass of magnesium, so 0.23 grams. Now, the next thing I've got to do is weigh the crucible, the lid, and the contents before it starts burning. So here's our crucible and lid, crucible, and we put the magnesium in there. Get the weight now of those three, and as I look at that, that says 28.18 grams. So I'll record that. Then it says mass of crucible, lid and contents after combustion, after burning it. So what we've got to do now is start the Bunsen burner. And put that on to very high heat, letting in as much oxygen there as possible, and now placing the crucible and lid on top. And what I'm going to do is get a pair of tongs so that I can lift that lid off the top there after it starts burning. Now, it does take a bit of time for the crucible to warm up and then to get so hot that the magnesium starts to burn. And often what's needed is to lift the lid off here to ensure that there is oxygen getting to the magnesium. And what we have to do then is wait. Right, it hasn't started burning yet. Just better make sure that's sitting right on the crucible. And here, of course, we've got a clay pipe triangle and our tripod and Bunsen burner and our heat mat here. So what you should be able to do now is draw a neat labelled diagram of all of the parts there of our apparatus. I'm just going to lift the lid again just to let in, make sure we've got some oxygen going in, and I can see that we are getting some burning now because there was some white coming off. I suppose we could call it smoke. So it's certainly burning at this stage. I don't want to lift the lid off too frequently because that will tend to let the magnesium oxide out, which I don't want to do. Just lift the lid again a little, and you can see there that, let's call it smoke coming out, a little bit of magnesium oxide. So what's happening as we watch this is the magnesium is combining with the oxygen. And what we could do actually is write an equation for that. You can see in your book, there's a space there for the equation, and what we can do there is write magnesium, or Mg solid, plus O2 gas produces magnesium oxide. So a balanced equation there, we would need 2 magnesiums plus 1 oxygen to give 2 magnesium oxides. Just lift the lid to a very small extent again, and again we've got magnesium oxide escaping. Now once I start lifting that lid and there's no magnesium oxide coming out, then we can reweigh the crucible and the lid and the magnesium oxide. Right, there's still a fair bit of burning going on there. Now you can see what's happening there as I lift the lid. At the moment everything is quite red hot. The crucible is red hot, and it looks as if the magnesium has finished burning. It's a little bit hard to be totally sure, because sometimes that coating of magnesium oxide can prevent further oxygen getting to the magnesium. But what I'm going to do now is turn off the Bunsen and reweigh the crucible and the magnesium oxide. Right, so I've turned off the gas now, and I'm just going to wait until that cools down, and once it cools down we can weigh the crucible and the magnesium oxide. Okay, so what I'm going to do now is put this on the weighing machine, the scales, the electronic balance, and get its mass. And hopefully you can see that that is a figure of 28.23. So I'll record that, 28.23 grams. So we're in a position now to calculate the mass due to the change in mass due to the combustion. And that difference there, you can see, will be 0.15 grams. The mass then of the oxygen that combined with the original mass of the oxygen is 0.15 grams. So as far as our ratio of mass of magnesium to mass of oxygen is concerned, we can say, first of all, the mass of the magnesium is 0.23 grams, is to 1.5 grams. If we use our calculator, we can then say that the ratio is 1:2. What we need to do is to divide our 0.15 by 0.23, and that gives us a ratio of 0.65. I'm just leaving that there to two significant figures. So our next question is, what is the mass of oxygen that would have combined with 24.3? So what we've got to do then is multiply that figure of 0.65 by 24.3, which gives us a figure of 15.8. Now, our equation is Mg solid plus O2 gas produces MgO solid. And to balance that, of course, we'll need a 2 in front of the magnesium and a 2 in front of the magnesium oxide. So what we can say as a conclusion to this experiment is that we had 0.23 grams of magnesium combined with 0.15 grams of oxygen. Now, the other thing that we can add to our conclusion is that the mass of oxygen that was expected to combine with 24.3 grams of magnesium is 15.8 grams. So this is very, very close to what was expected. Now, when we look at the discussion where it says the theoretical mass of oxygen that combined with 24.3 grams of magnesium is 16 grams, if this is not what you got, give reasons for the discrepancy, or give reasons for the difference, why it is different from 16. Well, we can see there that the mass is slightly less, that is 15.8 instead of 16. Why might that be the case? Well, certainly there is errors. We would expect errors in the weighing of the magnesium to begin with, the 0.23. There is uncertainty in that measurement. If we have a look at our instrument over there, we can see that it only measures to the second decimal place and not further on. So what we've got is a slightly reduced amount of oxygen, in other words 0.2 grams. So to account for that, as I said, it could be due to the level of uncertainty in our measurements, not only of the magnesium but also of the magnesium oxide. Now, the other thing that we would have noticed as we lifted the lid was that there was some vapor, some dust, some smoke of magnesium oxide escaping. So what we would have there is a slightly smaller mass of magnesium oxide than we would have expected. So we would have expected that figure of 28.23 to be very, very slightly more. So that would be another reason for the discrepancy. So what we have shown in this experiment is that we have got a mass ratio that is in fact very, very close to what was expected.